This video is about multiplying algebraic terms. So we've already done collecting like terms, which is basically adding and subtracting algebraic terms. So now we're moving on to the next most obvious operation, which would be multiplication. And before we get on to how to multiply algebraic terms, it's important that we just remind ourselves of two important concepts. And the first is the one we did in our very first topic this year, which is the commutative law. And in particular, the commutative law of multiplication, which says that we can multiply numbers in any order we like. So if it's 2 times 7, that would be exactly the same as if we switched the order around and did 7 times 2. So that's going to be very important when we are multiplying algebraic terms. And the other one is from the topic, our last topic of index laws. So in the index laws topic, we learnt about how to write numbers in index form. So here we've got 5 and it's being multiplied by itself 3 times. So that would be 5 to the power of 3. So that 3 tells us how many times the 5 is being multiplied by itself. And this 5 here, this is called our base. So we've got a base, and we also have a power. And those two things form what we call index form. So over here, I've got the 5 again, but this time it's being multiplied by itself 6 times. So in the index form, this would be 5 because it's the number 5, and the power would be 6 because that's how many times the 5 is being multiplied by itself. So let's move on to how to multiply algebraic terms. This is very important. When you are multiplying expressions, we do not care anymore about like terms. And I know we've spent a lot of time on like terms lately, but do not be looking for like terms when we are multiplying algebraic terms. It does not matter. So what we're going to always do with our algebraic terms and our final answer is we need it to be in the form where there is a coefficient first, for example, any number, and then the pronumerals will follow. So for example, 2b. We do not write b2 the way we write algebraic terms. So it must be the coefficient that comes first, followed by the pronumerals, whether there be many or just one, that's the order. So for example here, when I have an algebraic term without a coefficient, I know that there's an imaginary 1 in front. So I can multiply the coefficients, so 4 times 1, that gives me 4, and then I'll put down whatever pronumerals there are. So there's a b, so my answer is 4b. Not b4, but 4b. Now over here, we have m multiplied by g. Now, there are actually two possible answers for this. When we multiply m times g, we write it down as mg. Okay, because in algebra, that time sign over here is imaginary. We actually don't need to write it. So really, I can just remove it, and my end result would be mg. But because of the commutative law, it means that the other answer we would accept would be gm, because we can multiply these terms in any order, and the result will be the same. So I could start with m if I wanted, or I could start with g. So either answer is fine. Here we have a times d times e. We know we've got these coefficients of 1, but really when I multiply 1s, I just get 1. So I'm not going to write that down. But I will multiply the a by d by e, and I'll get a d e. Just like before, you could have e a d or d e a. Just choose one order and stick with it. So here we've got coefficients this time of 5 and 3. When I multiply them, I get 15. And when I multiply p by q, I get pq. We're starting to introduce some negatives, so that's where we pay attention to the signs first. If you have 2 negatives, they will make a positive. I don't need to write down the positive, but I do know my answer will be positive. And 7 times 2 is 14. So we get 14. And then my coefficients of r and t make 14rt or 14tr. Now here's one with 3 negatives, and from our last topic of indices, we should know that when you take a negative number and you raise it to an odd power, so for example, if you had a negative cubed, then it would be negative still. So in this case, we've got 1, 2, 3, these make a plus, and then that plus and that minus together make a minus. So we know we've got a minus in the end. So if we have an odd number of negatives, it'll be a minus. Even number of negatives, it'll be a positive. So we've got 5 times 4, that's 20, times 3 is 60. So I actually do the signs separate to the actual whole number part, or the number, sorry, at the front. So I've multiplied, worked out what happens to the minuses, then I've done the integers at the front, and now I'm going to multiply the G by the H by the W. That gives G, H, W. Just squish that in. So let's step it up a little bit more and do questions where there are powers. Okay. So with the first slide, I did remind you that if we have something like 2 times 2 times 2, we can write it in index form as 2 cubed. And so the exact same rules apply for algebraic terms. A times A would mean that I'm taking the number A, or the pronumeral in this case, the pronumeral A, and I'm raising it to the power of 3 because it's being multiplied by itself 3 times. If I wanted to write this in index form, I wouldn't be able to combine them all in one. I'd have to write 3 squared because the 3 is being squared, and I'd then write 5 squared. So because these are different numbers, I know this is index form in particular, I have to split them because they've got different bases. And the same is the case with algebra. If I've got m times m over here, then that would give me m squared. And this n and this n multiplied would give me n squared. So I can't combine them and make an mn. What I'm going to do is just write it as m squared, n squared. That would be the most simplest way to write it anyway. You could do other things with it where you combine the m and the n, but this is what we are looking for. We're looking for an answer of m squared, n squared, or of course you could have n squared, m squared if you decided you wanted the other order. So here we've got a question that combines a few concepts. We've got coefficients of 2 and 3. I'm not going to worry about all these other ones here. Ones will not change those coefficients. So the 2 and the 3 are what really matter. That makes a 6. Then I've got a p times a p. That makes p squared. And then I've got a q here, which makes it q. Down here I've got a negative, negative, and a negative. Let's start with the minuses. They make a minus altogether because there's 3. And I've got 4 times 3 times 2. That's 4 3s are 12. Times 2 is 24. And then I have a u times u times u. So that u is being cubed. So I'm going to write u cubed. All right, lastly, I've got a little quiz for you, which you can do by yourself. And on the next slide, I have the answers. So now's a good time to pause the video, attempt these 4 questions, and then mark your answers. And if you get a lot wrong, I think it's time then to go back and re-watch some of my explanations. And if you've got it right, you're ready to move on to some practice for yourself. So pause the video, give these questions a go, and then I'm going to keep going and reveal the answers. All right, here's the answers to the questions. Hopefully you didn't get tricked by some of the things like the 2 negatives here, or the negative over here and the negative here, and the coefficients of 1. So go through your answers, see if you can find your mistakes, and I hope this video helped.